Hi everybody, welcome to lesson 3 in which we're going to explore the zeros of quadratic functions. So we're going to play around more with looking at the zeros of parabolas. So sketch the graph of a quadratic function. So quadratics are x squareds, that's the parabolas that we looked at last week, that are concave down. That means it's an opening downward parabola and has zeros at -1 and 5. So let's sketch this. Where do I see my zeros? I see those on the x-axis. That's where we find our zeros, our x-intercepts. So it's at -1 and 1, 2, 3, 4, 5, and 5. But it's a concave, so it's a parabola going through those points there, but it's concave down. So that means the arrows plummet downward, and it kind of swoops around like that. So there's a sketch of my parabola there. There's my parabola. It's a parabola that's concave down and has those zeros. So state the equation of the axis of symmetry. So the axis of symmetry is that line passing through the middle. And the way that we get that is we average our zeros. I add my zeros together and cut it in half. I average my zeros. So -1 plus 5 divided by 4 is 2. It's a vertical line. It's x equals 2. There's my axis of symmetry. X equals 2. It's a vertical line such that the parabola gets reflected over it and it lands on itself. It's the mirror image. If I was to hold a mirror up to it, it'd look exactly the same. So that was just a review of the last 2 lessons we did. So a quadratic function has a 0 at x equals 3. So let's draw this. X equals 3, and an axis of symmetry at x equals -2. So there's the axis of symmetry. Where's the other 0? Where's the other 0 is the question. Well, remember, we can reflect over the axis of symmetry. How far away is it? It's somewhere over there. 1, 2, 3, 4, 5. This is 5 units. So that means I need to travel 5 more units this way. -3, -4, -5, -6, -7. I went 5 more this way. So the other 0 is x equals -7. So the axis of symmetry passes through the middle of the 2 zeros. So it's just using that whole idea of symmetry. Parabolas have this symmetry in them that we're going to use on our calculator and on the x-axis in these tables and graphs to explore them and to see properties that we can reveal. So try this on your own here. Here's a parabola. I mean, the x-axis is kind of hard to see. There's the x-axis and there's the y-axis. And I said state the zeros of this graph. Well, where do we look for the zeros? We look on the x-axis. So where do I hit the x-axis? I hit it at x equals -1 and x equals 6. State the equation for the axis of symmetry. Well, the axis of symmetry passes through the middle. There, so I can average them together. I can average my zeros together, and that will give me my axis of symmetry of x equals 2.5. So sometimes it's not a nice number. And we see here, yep, that's definitely the axis of symmetry. It definitely passes through the middle there. So that's x equals 2.5 is my axis of symmetry. And state the y-intercept of this parabola. Well, the y-intercept, that's just like it was for lines. Where do I cross the y-axis? At -5. The y-intercept is -5. We have our x-intercepts. Those are my zeros. And then the y-intercept is not that important. The zeros are really, really, really important. Yeah, the y-intercept's kind of just there. It's kind of just there. So find the real zeros of these quadratic functions using your calculator. Remember, we don't need to solve quadratic equations anymore. We can just graph them and be good to go. So let's see what we got here. Y equals x squared plus 6x. Nice. All right, take 2. X squared plus 6x plus 9. So if I graph that there, I should see a parabola. And there it is. There's that beautiful parabola there. Let's see if this messes it up. I might have just messed it up. Where'd it go? There it is. I love how it shows up down there. So there's that first one. Notice, where does it hit? Where does it hit the x-axis? That's my zeros. That's at x equals 3. So notice this only has one zero. It only has one real solution because it touches it at that x equals 3 and then turns around. Let's graph the next one. 2x squared plus, let me see it again, plus 2x minus 4. So here we go. 2x, let me go to the red one just to get a different color. 2x squared plus 2x. I'm struggling. I'm always struggling with this calculator. Plus 2x minus 4. So if I graph that one there, I see it touches the x-axis twice. I see it touches the x-axis 2 different times. It touches it at, let me shrink it down and move it over. Where does this hit the x-axis? Well, at x equals -1, -2. X equals -2, and x equals +1. So this has 2 real zeros. So again, how do I find zeros? I see where these parabolas cross the x-axis. That's a huge, I just solved the quadratic equation here. I just solved 2x squared plus 2x minus 4 equals 0. I didn't have to factor. I didn't have to complete the square. I didn't have to use the quadratic formula. I'm done. I used my graphing calculator to find the zeros. There we go. We're done. Let's look at this one. X squared plus 4x plus 7. Last one here. X squared plus 4x plus 7. Oh, let's go down to, whoa, it's clear. Let's go down to the green one. X squared, wow. X squared plus 4x plus 7. Graph that. And there we go. Notice each time I'm getting a parabola because I'm graphing an x squared function. Whenever we graph x squared functions, we end up getting parabolas. But what do you notice about this green parabola here? What do we notice about this green parabola? Does he ever touch the x-axis? Does he have any real zeros? No, he never hits the x-axis, so there's no real zeros. And I'll quickly complete the square. Let's say if we did the quad formula here. X equals -4 plus or minus the square root of b squared minus 4 times a times c all over 2a. If I was to quickly solve this using the quadratic formula, I actually end up getting the square root of -12 under my radical. And hopefully you remember from like a month ago, can we take the square roots of negative numbers? No, this is not a real number. That's not a real number. So what do you notice? When I have no real solutions, it never touches the x-axis. So the big idea here is, what do the real zeros represent on the graph? The real zeros are where the graph crosses the x-axis. Graph crosses or touches the x-axis. So the real zeros, these are our cases. We can have 2, 1, or 0. The parabola could cross through twice. It could kiss the x-axis and then turn around, so there's only 1 0. Or, like we saw when we solve things algebraically, graphically, these parabolas never touch the x-axis. And when we solve them, we get square roots of negative numbers. So we give up and quit, and we say there's no real zeros. So the real zeros, the whole idea of this lesson is the zeros are where I cross the x-axis. Find the zeros of this function using 3 different methods. So let's do it algebraically, graphically, and with a table. Algebraically, graphically, and with a table. So what I'm going to do is I'm going to type this into, let's do it algebraically first. Let's do good old algebra first, because this class is called Algebra 1. Let's find where it equals 0. So I'm going to GCF out a 3. Oh, this is so much fun here. And then I'm going to ask myself, self, what multiplies to negative 10? That adds to negative 3. What multiplies to negative 10 and adds to negative 3? Well, I got negative 5 and positive 2. So those are my factors. So my zeros are x equals 5 or x equals negative 2. Now, that wasn't impossible, but I just did all that work when I could just look at a graph. So let's go to y equals and look at a graph here. Let's go to y equals and look at the graph of 3x squared. I don't think I've typed in one equation correctly on my first try. Minus 9x minus 30. Let me go down here and clear out y5. So there's my graph. It's a parabola. I don't see the whole thing. It's there, though. You got to trust me that that parabola is there. We just don't see the whole thing. Where are my zeros? My zeros are where I hit the x-axis. So here we go. X equals negative 2, or 1, 2, 3, 4, 5, x equals 5. Done. That was a whole lot faster. That was a whole lot faster than factoring. I threw it into my calculator and looked at where I hit the x-axis. Using a table, I could also find my zeros. I can hit second table. And remember, when we do parabolas, we find the symmetry. We need matching numbers. There we go. I got matching numbers. Let me drag that table over. There we go. It went missing. Where are my zeros? Well, my zeros, I don't know why it's shrinking. Come back. Come back. Technical difficulties. Gotta love the technical difficulties. Nope. I'll try it again. There we go. So where are my zeros in this table? Where the zeros are where it equals 0. Where does it equal 0? At x equals negative 2 and x equals 5. So we can use technology to also solve quadratic equations. Just like we did, this was all Unit 8, was the algebra focus on quadratics. Now we're focusing on the graphical and tabular representations of them, where I could look at the parabolas and I can look at the tables to find things like my zeros and my vertex. We're almost done. A little more calculator skills, and I'm going to let you practice. So solve this equation to the nearest 10th. Solve this equation to the nearest 10th. Well, the first problem is it's not equal to 0. So let's start with that. I'm going to use the quad formula here because it's telling me to round it. This is telling me to round, so I'm going to complete the square or use the quad formula. So x equals positive 8 plus or minus the square root of b squared minus 4 times a times c all over 2a. And since it says the nearest 10th, I don't need to simplify that radical at all. I just need to type it into my calculator. So 8 plus or minus the square root of 104 over 2. So ready? Alpha y equals enter. Quit out of there. X equals negative b plus the square root of 104 all over 2. 9 point, what does it say to round to? Round to the nearest 10th. So 9.1. X equals 9.1. Or x equals 8 minus the square root. I'm changing the plus to a minus. The square root of 104 all over 2. Negative 1.1. So those are my two solutions, rounded. On my graphing calculator, I'm not going to be able to see those numbers. I'm not going to be able to see the zeros because they're irrational numbers, or those crazy decimals that never end, right? I kind of see them, but they're not exact. They're not exact there. So our calculator is going to find the zeros for us. Now, if you're on Desmos, you just click and it tells you them. But on the TI-84, we got to do a little bit of work. And the way that we're going to get there is by hitting second trace. Second trace. So ready? Second trace. And if I want to find the zeros, guess what button I'm going to hit? I'm going to hit 0. And right now it says left. So that means Mr. Blinky here, there's Mr. Blinky there blinking away. He's got to be on the left side of the 0 and hit enter. And now he's got to be on the right side of the 0. So I went to the other side of the 0. Now I'm on the right of it. And then you hit enter one more time and he jumps. And he jumps right to the 0 and it tells you what the decimal should be. Negative 1.099, which is what we had here. Wasn't that other decimal we had on the home screen? Negative 1.099. So I'll do it again. Second trace. I want to calculate the zeros, so I hit choice 2. And then there's Mr. Blinks, and now I want to go use the other one. So we have to be on the left and then the right. So you want to be before it. Mr. Blinks is currently at the bottom of the parabola working his way back up. He'll be back soon. Oh, there he is. So I want to be on the left-hand side, and then I'm going to jump over to the right-hand side, to the other side of it. Enter. Enter again, and boom, he jumps 9.099, which I'm pretty sure is exactly what we had right here, 9.099. So the way that you use your calculator to get irrational answers is second trace, then you're going to use the 0 function. And then you have to go to the left, and then go to the right. And then he jumps to the 0. So you have to go to the left-hand side of the number, the right-hand side of the number, and then he jumps. Left-hand side, right-hand side. So for this one here, solve the following quadratic equations using your graphing calculator. So what I want you to do is find the zeros. Find the zeros by using that second trace technique. So second trace, 0. You go to the left side, and then you go to the right side. So the first thing is it has to be equal to 0. So for something like this one, you need to subtract away 11. So for this one, you have to do x minus 2 squared minus 11 equals 0. That's the one you have to type into your calculator. Here you have to get it equal to 0. So that's how we can use our graphing calculator to solve quadratic equations. We can use the 0 button, second trace. All right, that's all I got to say about zeros. I'll see you guys in the next video, which guess what? Is about the zeros again. I'll see you then.